Hi friends, welcome to our channel. This is Kishore Parvalsa. Please subscribe our channel for more videos. Please support to me. I want your support. Okay, I need your support. Okay, today we are going to discussing about losses in AC transmission line. Losses in AC transmission line systems. Okay, so there are different types of losses in AC transmission line system. There are different types of losses in AC transmission line system. Okay, in that one is the corona effect. In that one is the corona effect. Okay, which is very dangerous effect which is influenced on the transmission line conductor. Okay, and second one is the skin effect. And second one is the skin effect. Okay, which is also very all those are very dangerous effects in influenced on that particular transmission line system. Okay, and third one is the proximate effect. Third one is the proximate effect. And fourth one is the Faraday effect. And fourth one is the Faraday effect. Okay, fourth one is the Faraday effect. So these are the different types of effects which is influenced on the particular AC transmission lines, particular AC transmission line. Okay, so coming to the corona effect, coming to the corona effect which is generally produced. Okay, so let us consider one conductor. Let us consider one conductor. This is conductor. Okay, so whenever current flowing through the conductor, then some flux will be producing. In that conductor. Okay, according to Faraday law, whenever current flowing through the conductor, then some flux will be producing. Here conductor means here that is like a transmission line. That is like a considered as a transmission line. Okay, so here, so whenever current flowing through the conductor, then some flux will be producing. If suppose here generally this conductor is generally used as a transmission, mostly ACSR conductor. ACSR conductors mostly we have to preferred in case of transmission line system. Okay, so these are the mechanical strength also. The mechanical strength of the ACSR conductor is very high. Okay, when compared to the aluminum different types of conductors. Okay, so that's why most we have to prefer to the ACSR. Okay, so here whenever current flowing to the conductor, then some flux will be producing in that particular transmission line. If suppose any coil side of the conductor, is breaking, at for example, if you want to go for writing like a remote sensing areas, in that remote sensing areas, so there are different types of transmission lines will be going like that. Okay, so whenever the breaking, whenever due to some lying of something, some branches of trees, or otherwise due to corrosion effect, if suppose the conductor may be breaking, at that instant of whenever current flow into the conductor, then the flux will be producing. So due to that flux, here whenever the breaking coil side of the conductor, here also, then what happened here, whenever the breaking coil side of the conductor, so then automatically here the flux which is totally occupied surrounding of the conductor, Okay, so this is called as corona effect. So the corona effect can be simply, we can judge as the hissing noises. The hissing noises produced surrounding of the conductor. Is called as corona effect. Okay, whenever current flow into the conductor, then some flux will be producing. This flux will be taken to influence on, so with respect to air, through the media of air, which is totally wounding on total surrounding of the conductor. Due to that resultant, some hissing noise is produced. Due to that hissing noise, at that instant of time, some violet color sparks, will be coming at surrounding of the conductor. Okay, at the surrounding of the conductor. So these are the different types of major problems, mostly which is occurred at remote sensing area, only. Okay, so this is the corona effect. Okay, so coming to the skin effect, here let us consider this is conductor. This conductor. Okay, same conductor we have to take. So here coming to the skin effect, here the current which is only flowing on only surface of the conductor, which is only flowing on surface of the conductor. There is no current flowing only in inner side of the conductor. There is no current flowing in inner side of the conductor, which is called as skin effect, which is called as skin effect. Okay, here, so let us consider this is a conductor, same conductor. So whenever here the current which is only flowing on surface of the conductor, here the current which is flowing only on surface of the conductor. So this is the conductor. The conductor may contain some diameter, okay, some area of cross section also there. So here the current which is only flowing only on surface of the conductor only. Here surface of the conductor only current flowing. Okay, here only surface of the conductor flowing. So inner side of the conductor there is no current flowing. Inner side of the conductor there is no current flowing, only the current which is flowing only surface of the conductor. Okay, so here the some different types of internal problems is there. Why? Because here the conductor is not good conductor. Here if suppose if we want to generally not using any good type of material, so then only the current which is doesn't flow from the how much amount of supply we are giving to the input, that much amount of supply will be not coming to the at the output of the conductor, at the output of the conductor. Okay, so must should be, if we want to so transmit the power at that instant, we have to use the proper good material conductor, material conductor we have to use. So let us consider for the good material to the transmission through the power transmission. ACSR conductor is the good conductors. ACSR conductor is the good conductor when compared to the all different types of AAAC conductors, aluminum conductors, all those conductors. Okay, so coming to the, so here the current which is flowing only on surface of the conductor, there is no current flowing in inner side of the conductor. This is called as skin effect. Okay, so which effect will be majorly comes to the we are not using properly good material conductor. Okay, so that is the skin effect. And coming to the proximity effect, here the proximity effect which is influenced between the any two lines, okay. Let us coming for the, so this is like a, let us consider for a, one is the transmission line. Okay, let us consider for a, what is the transmission line, and second one is the, let us consider any communication lines we have to take. Let us consider this is like a radio communication. Let us consider this like a radio, some FM radio communication lines. Okay, so whenever, so here from the generating station, here from the generating station, some current will flowing through the entire transmission line. Okay, at the same time from the particular station, from FM station or some radio communication line station, some signal will be flowing. Now some signal will be flowing to the entire communication lines. Some signal will be flowing to the entire communication lines. If suppose if you want to go for the remote sensing area, if suppose the distance between main transmission line conductor, okay, the distance between main transmission line conductor as well as communication lines conductor, distance will be very low, then only it take some ionization takes place between the those two conductors. There only some ionization takes place between the those two conductors through the media of air, because all the conductors which is placed on so outermost atmosphere, in the outermost atmosphere, so there may be a, so may contains air basically. So okay, so air is the good conductor, already know that air is the good conductor. So that's why with the influencing of air, surrounding of the conductor here to the influence of air, so total both two conductors which is ionization takes place. Due to that ionization, resultant flux will be weakening. On that both transmission line conductor as well as radio communication lines. Okay, due to that, so the disturbance of, due to that resultant, what happened here? So the disturbance of communication lines, as well as here also. So finally reaching of output power at the load center we can't reach. Why? Because here the total flux will be weakening here in that particular conductor. Okay, so that is happened in that main transmission lines also. Okay, so this is the called as proximity effect. So motion should be the lines between the lines. For the lines means here both main transmission lines as well as radio communication lines. The distance between each lines minimum may contains to 6 meters apart between two lines. Then only we can eliminate to the ionization takes place between the those two conductors. Okay, so this is the proximity effect. Then only you can overcome like that. Okay, so the distance between two conductors may contains minimum 6 meters apart. Then only you can reduce to the proximity effect. Then only you can reduce to the proximity effect. Okay, so these are the problems. Different types of problems will be coming sometimes. Okay, so coming to the Faraday effect. Coming to the Faraday effect. Here the Faraday effect, which is generally coming to the under no load condition. Okay, so which is not basically condition on the at load center. So whenever the load which is connected, so there are different types of losses will be coming. That is like corona and skin effect and proximity effect. These are the different types of losses. But if you want to go for the Faraday effect, if you want to go for the Faraday effect, which is generally influencing on under no load condition, whenever we are connecting doesn't connect to the load, then only the Faraday effect will be occurring. So which is mostly occurred at no load condition. At no load condition, the receiving end voltage is higher than the sending end voltage. At no load condition, the receiving end voltage is higher than the sending end voltage. So at that instant, we can simply call it as Faraday effect is acted. Faraday effect is acted. Okay, what I am saying, I understand. So here the receiving end voltage, here the receiving end voltage is higher than the sending end voltage at no load condition. At no load condition, at that instant is called as Faraday effect. So these effects are sometimes it happened. Okay, sometimes it happened. Basically, this is the not major effect. So here the major problem effects is maybe corona effect one, second one is the skin effect, and third one is the proximity effect. Its Faraday effect is the not major effect. Okay, so these are the sometimes it's happened. Okay, so friends, so this is today our class. So for more updates, please subscribe my channel. Okay, please support me. Okay, I need your support. Thank you very much. Thank you.